Renee Sieber, who is the professor of geography and other things at McGill University, will talk about communicating winds or storms via natural language processes of social media. Another interesting topic, as my colleague Jim Baker just sent me a note saying, thanks for saying his name, but he said, this is really fascinating to have so many different things all together. And I think this is good. Hopefully it's a benefit to us all. It certainly is to me. So thank you. Over to you, Renee.
Thank you, Gordon. And I will be my own timekeeper, unless someone wants to yell at me and call time. About is fair play. I'm reporting on a project we have with Environment and Climate Change Canada on communicating climate change with artificial intelligence. So our question is, how do we make sense in real time of social media coming from the public about extreme weather events like snowstorms? During snowstorms, social media can be valuable, for example, for gauging where affected people are obtaining their information, reacting to it. And in fact, we have a separate social network analysis sub-project to try to gauge where people are actually getting weather information from, effectively disseminating useful information to affected people, and providing situational awareness to crisis managers. Okay, social media has tons of advantages. It is a high volume and comes in very quickly. And you can get a lot of inference about how people are reacting to extreme weather events. But, you know, if you're a crisis manager, you can probably comprehend 100 tweets and maybe even 1,000, but what about 100,000 tweets? Social media can be redundant and filled with noise. It may have very little grammatical structure as well. So we look to artificial intelligence, and because we're looking at text, specifically natural language processing, to analyze these large volumes and the rapidity of data, to filter out irrelevant information, and to help us extract value from social media so that we're all more resilient in the face of extreme weather events. Sorry, I haven't been telling you to advance the next slide. Sorry about that. How? So this is the slide that says we developed several NLP models for Twitter snowstorm data. We started with a supervised classification. So I'm going to describe the two predominant methods of NLP in artificial intelligence: supervised and unsupervised classification. We began with supervised classification, which has become a standard in the crisis management literature. We tested its performance on tweets related to the Newfoundland snowstorm over the week of January 18th. We identified a few issues that are key to being able to effectively analyze user reactions, namely the gold standard for training the model, crisis NLP, proved to be somewhat inadequate for snow. A lot of the tweets ended up in two large categories called other useful information and irrelevant information, and that doesn't gauge the public reaction very well. So to have this work in the weather community, labels need to be relatively fluid. So I'm talking about supervised classification. What does that mean? This is a process that organizes content into predetermined categories. And what's nice about it is it can categorize in near real time. But the caveat is it requires an enormous training data set. And what do I mean by that? I mean a large corpus of data that has been classified manually, and it's usually done through a crowdsourcing platform like Amazon Mechanical Turk. Our model was trained, as I mentioned, with the gold standard called Crisis NLP, with some 16,000 tweets, primarily from floods, hurricanes, and earthquakes. So you can see where there might be some problems emerging. But to give you a sense of the categories of supervised classification, here they are. So you can see that there is a kind of a universality. of these categories, very useful for crisis managers, perhaps less useful for people who are doing climate modeling or weather modeling. Here's one, infrastructure and utilities damage, which tries to gain from the tweets that are being contributed by individuals reports of damaged buildings, roads, and bridges, or the disruption of utilities. Sorry, how? I'm still forgetting to tell you to move to the next slide. The next slide, please. Here's our classification of the snowstorm. It's important to mention that you actually need to filter the tweets and to geofence the tweets ahead of time. At the bottom, you'll see the various filtering hashtags. You don't always need to use hashtags to do the filtering that we used to harvest our tweets. What is of note is, and this is a logarithmic scale, is the vast number of tweets that are ending up in other useful information and non-related or irrelevant. So next slide. So you can see examples of the classified tweets. It's nice to look at the very bottom for irrelevant information, and you can see probably crisis managers don't need someone being able to nail the landing on the stool jump to effectively address this winter storm issue.
Just checking, Renee, I'm not sure we're on the same slide that you're looking at. So we're on.
So sorry about that, How. I'm zipping through. So you should see a slide number, you should be on slide number 7. And sorry, Vicky, and sorry, Bohan.
Oh, we're going the wrong way.
Are you there?
Yeah.
Just
Can
slide.
you see, Renee?
Can you see slide 7 of the boxes of injured, dead, donations, irrelevant information?
Oh.
Yes, slide 7. Do you have it?
No, we're on slide 16. No, wait a minute. I'm not sure which one we're on. There's one that boxes with dead people on it.
Keep going. Now advance to the next slide. So how? I'm my worst timekeeper and slide manager. Here are some slides that ended up in the other useful, and you can see perhaps that we may very well want to collect these kinds of tweets and categorize them differently. Next slide. Then we moved on to unsupervised classification because we found we were missing a lot of tweets. Unsupervised classification, in this case we use topic modeling, categorizes a corpus when the labels are not known. So when they don't fit into what people have already annotated as useful content. What happens in unsupervised classification is the top relevant terms are assigned to a cluster and they can be interpreted, and hopefully we can find these emergent topics and we can label these emergent topics. And the preparation is less labor intensive because you do not need that enormous training data set, and you do not need to pre-train your model in that way. Next slide. We should note that we actually pre-trained both our supervised and unsupervised classifications. We have a number of supervised classification models. We have a number of unsupervised classification models. We pre-train them with contextual models because, and I give you an example here of flood. The word flood can appear in both flood of cache and flood waters. Obviously, we want the latter and not the former. And unless you do this initial step, you're not going to get the topology, the word topology. That's one of the things we did. There's also a challenge in doing either supervised or unsupervised classification on tweets because of what's called data sparsity or a lack of word co-occurrence patterns. You actually switch to a contextual model called BiTerm. I'm going to be reporting both on the results of one of our latent Dirichlet allocation models and also one of our sentence BERT plus k-means models. So next slide. This is what comes out of an unsupervised classification. So we have not labeled the topics here. They're called topic 0 to topic 8, but part of the process of using unsupervised classification is indeed doing that human intervention and doing the labeling. I put a box around topic number 4 because that does give you some sense of how unsupervised classification can tease out topics that are similar to the supervised classification. But one thing I want to point out here is both that there are logistical things or physical things, and there are also some kind of psychological things that you might want to be looking at when people are communicating this information. And also, it can be extraordinarily difficult to tease meaning out of either supervised or unsupervised classification, and that's a huge challenge. Next slide. Here is an example of visualizing snowstorm tweet topics. This is called LDA Viz. It's visualization software, and it's quite useful to understand the predominance of keywords in any one topic and also the disaggregation of topics. So you can see that topic 1 is quite distinct from a cluster of topics in the upper left-hand quadrant. So sorry about the mix-up there with the slides. Concluding the penultimate slide, there's 2 takeaways here. One is that, first of all, we looked at the way people react to weather. A takeaway is that we see these practical and emotional reactions, which can point to the need to attend to psychological as well as physical resilience. And by harvesting these tweets, hopefully crisis managers can better respond to extreme weather events. The reason that I have this table here is also to alert you to the fact that there is a lot of human intervention and human judgment calls that are required to use these typical kinds of artificial intelligence. It is not something that you can just pull off the shelf and use immediately without making decisions about the number of topics or the choice or the application of a training data set. So just some caveats as you go forward and say, I know Python, I know R, here's some tool I can use. You have to make a lot of decisions along the way. And our last slide, thank you. And you can follow me on Twitter or email me at renee.sieber@mcgill.ca if you'd like further information.
One more slide there, Hal. We want to get the one with their slide on. One more. Yep. There it is.
There it is. Thank you, Gordon.
We're glad that you use Twitter, since you can catch up with that guy with the 5-letter acronym south of the border on tweeting. I don't even know how to tweet, so I'll learn from all of you.